Hello friends, welcome to Learner's Planet. Friends, this is our fifth session for graphs. In the previous session, we have discussed the graphs when the origin shifted, right? We have discussed the graph of fx to f of x plus minus a, and we have discussed the graph of f of a times fx. In this session, we'll be looking for some more transformations or some different transformations. So let's begin the session now. Now friends, in this section we are going to discuss these transformation, that is when fx is transforms to f of minus x, or f of x is transforming to minus of fx, then f of x is transforming to minus f of minus x. Now all these three transformations are very important. Just listen to me carefully or watch carefully. Now friends, when we convert fx to f of minus x, then exactly mirror image we have to see, right? Exactly mirror image when x is converting to minus x, right? F of x to f of minus x, right? Exact mirror image. Now fx is converted to minus f of x, then you have to see water image, right? In this case, you have to see water as well as mirror image, because x is being converted to minus x and further minus of fx is also there. So two transformations are there. That's why you have to see mirror as well as water image over here, right? I just take a simple graph before you, and then we transform that graph. Just wait for a moment. Now please just watch very carefully. This is the graph of f of x, right? This is the graph of f of x. Right? Now from this graph I am converting this to f of minus x. Now just watch carefully. This is the line, and you can see the shape that is changing, or that is getting inverted along y-axis, right? This shape is converted to this shape. This small arrow is coming this side, this bigger arrow is coming this side, right? That is an inversion along y-axis. Okay, so this is fx. So for this fx, this is f of minus x. Okay, this is fx, this is f of minus x. The inversion is happening along y-axis. Okay, now this is fx and this is f minus of fx. Now friends, I just wish to convey one more thing over here. If you draw this graph on a paper, and if you see back side of the paper, right, if you just turn the paper, you'll be able to see the mirror image of this graph. Right? So actually f of minus x is the mirror image of fx. Be very careful about it. If you really see this graph in the mirror, you'll be able to see this image, right? So f of x and f of minus x. F of minus x is the mirror image of this graph, right? Now from f of x to minus of fx, right? This is an inversion along x-axis. As it is, this graph is turned along x-axis. You can very well see that. So this is the graph of minus of fx, right? So if you draw this graph on a paper and if you invert it along this x-axis, you'll be getting this. So precisely this is what the water image, right? Suppose this is t, so water image of t is like this. If this is a, water image is like this. Okay, so this is precisely the water image. This is mirror image, this is water image, right? This is a horizontal inversion, this is vertical inversion. Okay, now this case is what? Minus f of minus x. That means mirror as well as water image. First of all, we are turning it around along y-axis, then we are turning it around along x-axis. So two types of inversions are involved over here. So that is mirror as well as water, right? Just pause the session, see the conversions very carefully, because these are very important. This is fx, this is f of minus x, that is mirror image. This is fx, that is minus fx, that is water image. This is fx, this is minus f of minus x, that is mirror as well as water image. Okay? And the important thing which I have told you is that if you draw this graph on the paper and if you see the back side of the paper, you'll be getting the mirror image of this graph, right? So that can be matched with this, right? So that's important thing, fx to f of minus x, fx to minus of fx, and fx to minus f of minus x, right? So if you know this sort of conversion, any graph can be converted, maybe log x, maybe e raised to x, maybe any other graph, right? So I hope you are getting me. You can see some of the examples over here. When fx is transforming to f of minus x, the curve f of minus x is the mirror image of the curve fx considering y-axis as mirror, right? So this is a mirror, this is the graph of f of x, then this will be the graph, this is the graph of f of x, the blue line, then this will be the graph of f of minus x. Just an inversion along y-axis, okay? You're just turning around the graph. Okay, you can very well verify the same thing by looking at the mirror. Okay, now here we are having the graph of y is equal to e raised to minus x. Now to draw the graph of e raised to minus x, you must be clear with the graph of e raised to x. Thus blue line represents the graph of e raised to x that we have already discussed in our previous sessions. Now x is converted to minus x. Now fx is what? E raised to x. So f of minus x is what? E raised to minus x. So what is happening? Here you have to take the mirror image, right? From f of x to f of minus x, it is converted. So you have to take the mirror image of this graph, right? So what will be the mirror image? You just turn it around along y-axis. Just twist it, okay? I'm sure you are getting me. It's this graph is mirror image of this graph, right? Suppose you have the graph of tan inverse x, that is this graph. Now if x is converted to minus x, you can just turn it around, just rotate it along this y-axis, okay? So you'll be getting the graph of tan inverse minus x. Doesn't matter whether it is tan inverse x or maybe tan inverse minus x, you just consider this as a graph of fx. So this is the graph of fx, and if you turn it around, you'll be getting the graph of f of minus x. Similarly, this is the graph of log x. Now x is converted to minus x, you just have to take the mirror image of this graph, right? Very easy, friends. Once you are conceptually clear how fx is converted to f of minus x, you can draw any graph, right? Any graph whenever it is converted to negative, right? This is log x, this is log of minus x. Now log x graph is this, so log of minus x graph will be mirror image of this, right? Just turn it around along y-axis. Very, very simple. Now suppose fx is converted to minus of fx, that means in that case you have to consider this x-axis as a mirror, and you have to turn it like this. This is like a u, you can say, and this is like opposite u, or we can say inverted u, right? This is fx, this is f of minus x, or you can consider this as the water image, right? If you just see this u in the water, you'll be able to see this u, like the inverted u, right? So this is what the conversion or the transformation of fx to minus of fx, right? I take some more examples. Now here we draw the graph of minus ex, right? F of x is ex, and here we are drawing minus of fx, that is minus of e raised to x. What you have to do, this is the graph of e raised to x. What you have to do, you just have to invert it along x-axis, right? This is what the water image of this graph, right? Or you can consider this line as a mirror and just invert this along this side or this axis, okay? So that is actually the water image. So you have we have discussed e raised to x, e raised to minus x, and minus e raised to x, right? From this to this, it's a mirror image. From this to this, it is a water image, right? Now the fourth thing is minus e raised to minus x, that is mirror as well as water, okay? I just show you that graph also. Wait a moment. Before that, we see the graph of fractional part of x. The graph of fractional part of x is this, right? These purple lines, right? Now if you have to take the minus of fractional part of x, you can just take them their water images. Very simple. Or consider this as a mirror and take the images, or see the mirror images, right? I just take one more. Here I am having the graph of sin x. This purple line is the graph of sin x. Now if I have to draw the graph of minus sin x, what I have to do? I have to invert this graph along x-axis, right? Consider x-axis as mirror and invert this graph, or you can say this is the water image, right? Now this is fx transforming to minus f of minus x, that is mirror plus water, right? I have already told you this is I just show you once again. This is fx, that is I just write draw f of minus x, lateral inversion, or we can say horizontal inversion. Then this is minus f of x, and this is first you, or you can, what you can do, you can take the water image of this, so that will be minus f of minus x. Okay friends, so in the case fx is transforming into minus f of minus x, you have to take mirror plus water images, right? Now here I have one example. First of all, fx to f of minus x, this is fx and we are converting to f of minus x, right? Now from f of minus x you convert like minus of f of minus x, so that will be the water image of this graph, water image of this blue line. This purple line is actual graph of fx, this blue line is the graph of f of minus x, and inversion of this along x-axis is the graph of minus f of minus x, that is this red line, right? Now here I take example of minus log of minus x. First of all, we are clear about the graph of log x, that is this graph, right? Now this is log x. Now x to minus x, that means mirror image. So we are getting the mirror image of this graph as this blue line. So this is log x, this is log of minus x. Now if we take the water image of log of minus x, we'll be getting the graph of minus log of minus x. So just turn it around along x-axis. You can see this graph, and if you turn it along this axis or twist it, you'll be getting this, right? Just a one fold you have to give along this axis. So log x, log of minus x, and minus log of minus x, okay? And if you wish to get minus of log x, then you just have to turn this graph along this axis, right? That you will be getting the graph of minus of log x. So I hope you are getting me how fx is converted to f of minus x, minus fx, and minus f of minus x. So if you are clear about the basics, you can draw any graph, whatever the transformations are asked, you will be able to do that, okay? Now friends, let's discuss the graphical transformations in case of modulus function. Now what happens when fx transforms to mod of fx, when fx transforms to f of mod x, and when fx transforms to modulus of f of mod x, right? Now let's read the steps carefully, and then we'll be drawing some graphs also. The graph of y of modulus of fx is drawn in two steps. Keep the positive part of the graph, that is above the x-axis, as it is, and draw the mirror image of negative part of the graph, that the part below x-axis, considering x-axis as mirror, or you can say water image you have to draw, right? So I just take one of the graph. First of all, here I am having a graph of y is equal to sin x. Whether it is sin x or any other function, we are interested in modulus of fx, right? So suppose it is the graph of y is equal to, if like fx, this is fx, and now we have to find out the mod of fx, right? Now the basic graph is that this complete line is the basic graph, right? That is the graph of fx, that is sin x, okay? So this is the graph of y is equal to sin x. Here you can see the blue line, that is below the x-axis, the blue curves, right? So when we have to find out the modulus of sin x, see what exactly happening, just listen to me carefully. When we draw the graph of sin x, some portion is negative, that means from pi to 2 pi this curve is negative, 3 pi to 4 pi the curve is negative, minus 2 pi to minus 3 pi this curve is negative, right? That means we are getting the negative values of y. But what happens when we take the modulus, right? Now y will never be negative, right? Because whatever the values you are getting for sin x, if it is negative, then also this modulus function will convert them to positive, right? So y will not be negative at all. So what precisely we have to do? From this graph, the portion that is below the x-axis is taken above the x-axis. That means what you have to do, you have to take the water image of this graph, right? Or you can say inverted image. So these curves will be converted like this. Getting my point? Okay. So what you are doing? You are taking mirror image of these graphs. So finally, modulus of sin x, the graph will look like this. Okay. Now you can see there is no negative part. That means below x-axis no part of the graph is there. That means y is always positive. Whether x is negative or positive, y will always be positive, right? So isn't it very simple? Now suppose I wish to draw the graph of modulus of log x. So first of all, what we have to do? We have to draw the graph of log x. That is this, that we have already discussed, right? This is the graph of log x, right? Now this is the part of the graph that is below x-axis. What we have to do? We have to turn it around, like invert it along x-axis. So you can see that this part is turned as this, right? The line is getting closer and closer to y, but it will never intersect y-axis, right? So we are taking this part over here, or we can say the water image of this part is this, or if we consider this axis as mirror, then this is the mirror image, right? So this red line is the graph of y of modulus of log x. Okay, y is equal to modulus of log x graph. Okay, it's very simple, friends. I take one more example. We are having the graph of fx like this. Forget sin inverse x. Suppose this is the graph of fx. Then we have to cut the part that is below x-axis and we have to take the water image of this, or along this axis we can say mirror image, right? So this part is cut and it's converted like this. Just a turn we have to give along this axis, right? So this is what the modulus of fx. Okay. Now suppose I have to draw the graph of y is equal to modulus of x square minus 4. Friends, we have already discussed the graph of y is equal to x square. This is the graph of y is equal to x square. Now if we deduct 4, it will come 4 steps downwards, right? So this will be the status, right? Now after that, the portion which is there below the x-axis, we have to take its water image, right? Or along this axis we can say mirror image, right? So this is the original graph of x square minus 4, and the portion that is below x-axis we are cutting it and we are just turning it around like this, okay, above the x-axis, as it is above the x-axis, right? So this red line is the graph of y is equal to x square minus 4. So you start with x square, then you go for x square minus 4, then the negative part or the part that is below x-axis is taken above x-axis, as it is a single turn you have to give, right? So each and every step is clear over here. Getting my point? Friends, the remaining transformations will be discussing in the next session. I hope you are getting me, and you must be enjoying the topic graphs as well. So see you in the next session once again. Bye bye.